Here we go. I'm going to move this just a little bit. Sorry. All right. Here we go again. Same ideas. We just did this. We're going to use this later on. Okay. That's what I reminded you of at the very end of the last video. Now, instead of evaluating by creating some log base b of b, like making our base the same as our argument, we're just going to expand. There's no evaluation here. All we're doing is spreading it out, just expanding it. So we're looking for some multiplication. We're looking for some division. And if there are powers along the way, we're going to use those properties. So basically what we're going to do is we're going to roll everything up all into one nice, neat little ball. Everything has a little bit of multiplication. Everything has some division. And there are some powers. Some multiplication, some division, and there are powers, okay? And we'll get to this one. This is, it looks daunting, but it's actually quite simple. Okay, I hope you can see it. I can hardly see it on my board, but if I move closer, I lose a whole lot. Actually, let's just do it. All right, I'm going live. What the heck? Let's just move closer and slide on over here, and we'll just look at this side. All right, we already know our properties, right? So we're just going to go ahead. Now you can really see this stuff while I work on it. I'm going to start way over here. All right. This is ln, or natural log. No big deal, just the inverse of Euler's number, right? No big deal. So we're just going to keep it as natural log. We don't have to create a different base or anything. We're just going to write it as ln. What we see here is a little bit of multiplication. So I'm going to show you what's being multiplied. 8 times x to the 5th, right? And there's some other multiplication down here. 3 times y squared. And what I'm going to do is I'm going to go ahead and quantify this and quantify that. Really don't have to, but I'm going to show it to you just in case, right? So we're going to expand this, and it says when we multiply, we just put an addition symbol in the middle and we keep the base the same. So it'd be the natural log of my first term, which is 8. And then we're going to add to it the natural log of that x to the 5th power. All right, and that's one quantity. I don't really need the parentheses, but I want you to understand this was my numerator. Okay, I'm going to write it in a different color. This is my numerator. Okay, so I've expanded this. I'm not finished, right? I have to throw my power, use the power property, throw it up front. So let me rewrite. Natural log. That's my numerator, all expanded. We're going to subtract and then subtract. We're going to create that quantity. And then we're going to distribute the negative after we rewrite everything. Here's my 3. It's the natural log of 3 times, so we're going to put an addition sign in here, the natural log of y squared. Okay, and then we're going to close the parentheses. I got in my own way there, but I should be able to work with that. I'm going to throw the power up front and use this quantity again, the natural log of 3 plus 2 times the natural log of y. Close the parentheses. Why do I have parentheses? Because I know I'm subtracting this plus this, so I have to distribute my negative to each piece. So let's rewrite the whole thing. The natural log of 8 plus 5 natural log of x minus the natural log of 3 minus 2 times the natural log of y. Okay? This is it. This is the entire expansion, right? This is a lot of work. Takes a long time to get from beginning to end. All right? Is it annoying? Yeah, it can be. It's not, simple 5 plus 3 is 8, but that's what we got to do in pre-calculus. Let's look at this one. What are we multiplying? We're multiplying 5 times r to the 5th. Now here's our problem. Look at this denominator. It's the square root of 3, right? Root 3 of t squared. I want to rewrite root 3, or the cube root of t squared. There, I got it right. And I'm going to rewrite it just like it said over on the other page when we started this. This cube root of t squared is the same as t to the 2/3 power. And if we can get used to that, going back and forth, maybe I'll give you a couple of those tomorrow just to keep going and going and going and getting you to realize that. But that's what this is. This guy right here. So I'm going to use that when I go ahead and expand this. So let's expand the numerator first. We're going to start with, cut this off, start here, log base 3, 5 plus log, say base 3 of r to the 5th minus this t to the 2/3 minus log base 3 of t to the 2/3 power. All right, now all I have to do is take my powers and throw them in front of my logs. There we go. Log base 3 of 5 plus log, I didn't write it, 5 log base 3 of r minus 2/3 log base 3 of t. There it is. Boy, this is a lot of work, right? A lot of work. There it is. I think I've run out of room. What I may need to do, we'll make it work. Here we go. Don't get scared. Scared? I'm scared. Let's do that. All right. Now, here's what you need to know. Don't break up anything that's quantified, anything inside the parentheses, any of these binomials inside these parentheses. That's an entity. This times this to that power, okay? So a minus 2 and b plus 4 to the 6th. Those are entities, those are quantities, those are going to be our arguments. All right, let's start to expand the numerator. It's log, and anytime it's just log, no base, it's base 10. We're going to say it's a minus 2 plus log b plus 4 to the 6th power. I'm running out of room. I'm going to cheat and put my subtraction symbol down here and write it out here. Log of 9 plus log, still ran out of room, darn it. B plus 4, close the parentheses, to the 5th power. I hope you can see that. Oh, it's so ugly. I'll shift it over as much as I can when I take my power and throw it up here. And then I'm almost done, right? I quantify this whole bad boy here just so I can remember to distribute my negative. And I don't want to forget to put this up here because there's another power. So let's rewrite log a minus 2 plus 6 log, remember, put that 6 up there, the quantity b plus 4 minus the quantity log 9 plus 5 log b plus 4. We got it all done. Except I haven't distributed my negative yet. So I need to make this minus, minus. Okay? That's all it is. So let me rewrite it where I have some room. I'm going to cheat some room out here. This is my final answer, log a minus 2 plus 6 log b plus 4 minus log 9 minus 5 log b plus 4. And that's it. Look at how long that is. Whoo! That is a lot of work. That's it for expansion. So we did expansion. We did some evaluation. Tomorrow, we'll condense. We'll take something that looks like this, and we'll see that we have minus, minus, and we'll say, there must have been division there. And we'll take that and we'll put that together. And we'll see, there's addition. These two things must have been multiplied, and this must have been a power because it's up front. And then we'll get to work on that. We'll do the same thing here. This one was a lot easier, wasn't it? A lot smaller. Real fat over here. I didn't realize I wouldn't have room. And we'll do the same thing. Minus, minus. This must have been some sort of multiplication. We'll do a little bit of detective work, and we'll condense, and it'll be great. You guys are going to be fantastic. Thank you for taking the time to watch this. This should help you with your homework. Any questions, of course, let me know tomorrow. We'll fix it right up. Thank you.